Hello everyone, welcome to solve this nice math Olympiad algebra problem. So here we have k plus 2 is equals to k, and we solve this problem for all the values of k. So here first we need to find all the roots of this equation, and at the last we will be verify that which of the roots are solution and which of the roots are extraneous root. Further, we solve this problem for two methods. I hope so you like both of these two methods, but if you have any other method in your mind, so please don't hesitate to write this method into the comment section. And now we move toward the solution of this problem from first method. So here first I can explain why we solve this problem for two method. The reason is that if in your exam the question statement is that you need to determine the values of k, or you need to determine the roots of this equation, so in that case you solve this problem from first method. But if in your exam the question statement is that you just directly determine the solution set of this problem, in that case you move towards our second method. But both of these two methods are valid to solve these type of questions. And now we move toward the solution of this problem, and here our target is to find the values of k. So in that case we need to take squaring on both of the sides. So when we apply squaring, it will be written as k plus 2 whole square is equals to k square. And now further in the next step, we move this k square from right hand side to the left hand side, and it will becomes k plus 2 whole square minus k square, and this whole equation is equals to 0. And now here further in the next step we need to use here this nice algebraic formula. You know about that. If we have a square minus b square is equals to a minus b times of a plus b. So according to this rule, we write the left hand side of above equation as, so first you have this is a minus b, the value of a is k plus 2 minus the value of b is k, into the second factor is a plus b, the value of a is k plus 2, and plus the value of b is k, and this whole equation is equals to 0. And now here further in the next step we need more simplifications, and you see here this is minus k and this is plus k are cancelled out by each other, and here we obtain 2 only, and here we add k plus k becomes 2k and plus 2, and this whole equation is equals to 0. And now here further in the next step we need to divide both of the sides by 2 in order to remove this 2 from here, okay? So that we divide both of the sides by 2, and we obtain this 2 and this 2 are gone, and we get the remaining values are this is 2k plus 2 is equals to 0 divided by 2 becomes here 0. So here we move this plus 2 to the right hand side, and it will becomes 2k is equals to minus 2, and further again we divide both of the sides by 2, so you get this 2 and 2 are gone, and we easily obtain the value of k is equals to minus 1. So you see here in the first method we easily get the value of k, and that is equals to minus 1. And now here in the next step we need to verify that is this value of k be the solution, or is this value of k be the extraneous root. For this we need to copy down given question statement. Here it is k plus 2 equals to k, and we substitute k equals to minus 1 on both of the sides, and we check that is this satisfied our given question statement or not. So when you put it here, it will becomes minus 1 plus 2 is equals to minus 1, and you see here minus 1 plus 2 becomes plus 1 equals to minus 1. You see here this is not possible case, or in other words we say that it is not possible a positive 1 equals to negative 1. So this means that the value of k equals to minus 1 is not satisfied our given question statement. Here we just called that k is equals to minus 1 be the extraneous root of the given equation. Okay, this is the extraneous root because it does not satisfy our given question statement. So in other words we say that the roots which is not satisfied our given question statement is called the extraneous roots, and the roots which is satisfied our given question statement is called the solution set of this equation. So here you see that we cannot get any other value of k which is satisfied our given equation. So this means that this question has no solution in general. So this is the final answer of the given question which we get here in the first method. And now here we need to move towards our second method. So that our second method, for second method we need to copy down given question statement here. So that our given question statement is k plus 2 is equals to k. So here our second method be the very straightforward method, and here we quickly get the values of k, or we quickly determine about the solution set of this problem. So here in this method we move this plus k to the right hand side, and it will becomes 2 is equals to k minus k, and we obtain 2 equals to, this is negative k and positive k are gone, and we get 0 only. You see that 2 equals to 0, and again this is not possible case. It is not possible that 2 equals to 0, and you see here we cannot get any value of k in the second method. So this means that this question has no solution, because we cannot get any value of k which is satisfied our given question statement. So this is the final conclusion about the solution set of this problem, and this is the final answer. And thank you so much for watching this video. Please subscribe to my channel for more exciting videos.